to learn from nature. Nature, when confronted with environmental pressures, adapts quickly, often within several or a dozen generations. Take the white-spotted moth, whose native habitat is London. And when I visited in the 70s, I was astonished at how soot-covered everything was. And the white-spotted moth was no longer camouflaged on bark. It literally changed its spots. So we humans, occupants of the habitat we call the world, find ourselves in a like predicament. We're facing environmental challenges and we must adapt, and we must do so quickly, achieving carbon neutrality by 2030. So the US population has tripled since 1900, and by 2030, California, Texas, and Florida will each have increased by 12 million people. So a lot of new homes are going to get built. And who's building those homes? Developers, production builders, are building 75% of all new homes. The developer is the elephant in the room. Now that's the challenge, but here's the opportunity. 75% of all homes built in 2030 will have been built from 2010 forward. So if we can engage the developer, the production builder now, we can get this done. So my colleagues and I have been called up to duty. We've been asked to research and uncover the latest technological innovations to chart a critical path for a sustainable future. Let's call us Team 2020, and let's include everyone in this room and everybody beyond this room committed to changing the business as usual of industry. Those of us who are eco-home reading, LEED APing, green spec toting, carbon sequestering, zero-scaping biomimics. Team 2020 must define a new species of building, one that doesn't operate on the fringes, but one that operates at scale. To effect real change, we must engage the developer builder. So the first part of my talk, I'm going to focus on operational energy, the energy used in running our homes. The second part of my talk, I'm going to talk about embodied energy. So low first cost. I've met with builders and I've asked them, who are you? What drives you? How do we do this? And they tell me green is good. It helps them separate from the competition. But the risks have to be low. They need low first cost because, after all, they're profit driven. So we need to look at upfront costs in the range of 3 to 5% because expensive strategies like passive solar, the savings are realized by the owner, not the builder. So what are some options in front of us? Someone asked about traditional building. I grew up in Vermont in a home not dissimilar to this. And every time I go home, I'm struck with how the traditional house is different from that in Virginia, where I now live. Now, there are twice as many heating degree days in Vermont as in Virginia. Now, these two homes built in the 1770s are both 4 rooms. But the Vermont home has 4 on the floor. The Virginia home is 2 over 2. So what's interesting about this is the Vermont home has more mass to surface area than the Virginia home. Now compare that to 2 homes developer built in the 1970s. Now we have air conditioning now, so we don't have to think about these things so much. Now, curiously, animals in the north are bigger typically than in the south, like the white-tailed deer, because the northern species has more mass to surface area. So nature has something to teach us. In fact, the biomimicry focuses on the genius of nature and what we can learn from nature. And nature, with 3.8 billion years of research and development, has it all over modern science, which is but a yearling. So take, for instance, the compass termite, who has a wedge-shaped nest that is aligned north to south. And the north side is actually insulated with something akin to a straw bale. The south side is got thermal mass using cob. And then there are tiny capillaries on the exterior that take in air and a central chimney that exhausts it. And at night, the termites actually take small balls of mud and they close down those apertures to retain the heat. Now, these passive solar strategies are not new to us, and yet rarely implemented at the community scale. So I think it's fundamental, if we're to engage with the developer-builder, that has to happen at the planning level. How streets are laid out. And then the different home models, whether the front door is facing north, south, east, or west matters. And with 50% of the US population living in suburbs, this is important. So we designed this community for the University of Illinois at Champaign-Urbana. And we laid out the streets and the buildings to take advantage of thermoregulation to optimize passive solar. And this was a competition we did in Charlottesville for Civic Corps, which we won. And the Central Civic Hall is organized around the same principles as the compass termite. Now, Rick asked me to talk about size. Now, in America, we love size. We love big, right? We invented the Big Mac. But here's what I think about big. I think big is boring. Here's what I value. I value clever. Take this this apartment by Gary Chang in Hong Kong, 380 square meters, 24 rooms. It's like the Swiss Army knife equivalent of an apartment. And what I love about it is a room is only a room when you're in it. When you're not cooking, the kitchen slides away to reveal a wardrobe where you put on your smoking jacket. It's very clever. This is my kids' room. I value fun. The kids their rooms have a small footprint, but they're tall and they have a common loft. And that loft over the years has morphed from playroom to castle to library to man cave. I value community. We became developers ourselves, and we have developed a 10-home community in Charlottesville, Virginia. There was a plot of land across from our house, and we thought we'd better take control of it before someone else did. And we designed the lots so that they were small, and instead created a large common area. So more community, less mowing. And this idea of community operates at the scale within the buildings and between the buildings. So the two Habitat for Humanity houses at the top right have a common courtyard. And then within the homes, they're arranged as loft-like organizations so that all the activities of the house converge in one space. I value nature. This house has the bedroom quarters and the living quarters separated by outdoor space. So you actually have to go outside to go to bed at night. But what's really interesting is, as nice as the rooms are, the inhabitants spend their days outside. And I value cool. So here's what these things all have in common: fun, cool, community, clever. They're ways in which we engage in a positive way with our environment. I think big is passive. Studies are now showing that it's actually the pursuit of happiness, not the attainment of that goal, which makes us happy. So I think it's that active engagement. And that's why I think that size is a false prize. Now, if we're talking to builders, and we're talking about how to bring them into the fold, if you like, we need to consider how to improve the building envelope in a way that is builder-friendly. So this upper row shows you what would be a typical construction, 2x4, sheathing, bad insulation, and so forth. And then the cost per square foot associated with that, which I've been told by local builders is what they assume. So if we were to take passive house strategies, we would turn that into 2x6 construction. We would super insulate it. We'd use wet blown cellulose, for instance. We'd do the wrapper around the whole thing with rigid insulation. And then we'd use triple pane windows. Now, this can be done, I'm told, by builders who do this within a 5% margin. So we can achieve our goals of an 80% reduction in energy costs with a builder-friendly approach. This is one way we could do it. Now, this is the passive house approach. And the idea behind it is that you insulate the bejesus out of the envelope until you eliminate the need for heating and cooling, and you only have fresh air. So we've solved the operational side. But embodied energy, and Dennis has already talked a little bit about this, is a very important part. If we're to really think about carbon neutral, we have to consider the energy that goes into constructing our buildings, which accounts for something like 25% of the total energy use of a building over its lifetime. So that's a big number. And of all those materials that we put together to make our homes, concrete is the biggest culprit. We produce so much concrete in this world that for every person on Earth, every year, we produce 2 tons of concrete, which, as Dennis mentioned, well, actually, my figures are a little higher, 5 to 10% of global greenhouse gases. That's an astonishing number. So what solutions do we have before us? So I love this. This is called Rebirth Brick. It uses some recycled content, which can, of course, reduce energy inputs for materials. And what's nice about this is the aggregate is from debris from earthquake zones. And then compressed earth block is another option that takes commonly found materials on site, like sand and clay, mixes them with a binder, and actually makes it less expensive concrete. Now, Drexel University is producing a concrete without applied heat. Now, Portland cement requires kilns run at 1450 degrees centigrade. So that's where the energy is, right? So Drexel is using an alkali activated cement using industrial slag. And their cement is 97% less energy than Portland cement. Now, the Romans, curiously, were already doing this. The Romans were making marine cement that is still intact 2,000 years. Portland cement in seawater, 50 years. So stronger, durable, no heat applied. They did it by mixing volcanic rock, lime, put it in form, submerged it in the seawater where it would get hot, and a chemical reaction would take place. So the Romans used chemistry. Nature uses chemistry. Coral reefs are limestone, CO2, and seawater. So a company in California named Calera is using the same process to produce lime. So while we're talking about CO2, after all, instead of producing or materials instead of producing CO2, consuming CO2. I love this building, which has this faceted facade that increases the surface area by 200%. and there's a coated pigment on the facade that actually breaks down pollution, the equivalent of 1,000 cars per day. So that's pretty impressive, I think. So we can't talk about embodied energy without talking about transit. And when we're going after a lead project, we can get points for renewable, recyclable, local. But if you're at all intelligent, you have to ask, well, okay, we get points, but what does it really mean? What's important here? So to help us kind of disentangle these issues, we embarked on a materials mapping project where we're really looking at embodied energy and transit inputs. So the idea is that this would become a website eventually open to the public for use. So you would input, your keywords or the CSI number or your zip code. And then some products would come up. Now we're focusing on bio-based initially, which was actually something that the Building Green folks suggested last year at this event to me when I discussed this idea. So up would come a couple products, and one of them might be a product by EcoVeda that's mushroom-based. And you would look at it and you'd consider whether it was appropriate to your project. And also it would tell you what the transit inputs were, and so that you could decide whether using that product was better from an embodied energy standpoint than a conventional rigid foam insulation produced in your own backyard. And in this case, if your cowgirl architect there in Texas found out that, in fact, the material produced in New York State is 8 times less embodied energy than conventional rigid foam produced in our own backyard. But I think if we were to get to net zero, we really have to retool our thinking. Conventional building practices use either additive, heat, beat, and treat, or subtractive, where, say, you take a tree and you whittle it down till you get a 2x4. So what's really exciting is that rapid prototyping, the patents are going to expire next year. It was actually patented in 1984. So all these companies, such as Nike, are about to produce shoes through rapid prototyping. That sole there is rapid prototype. And architects are beginning to envision building components and then whole buildings using rapid prototyping. So our waste, the whole concept of waste, starts to completely be revolutionized. So others are taking a look at nature's assembly line. This architect, Swedish architect, an architect's great. This Swedish architect is flushing bacteria through sand to create a structurally sound sandstone in about 24 hours for use in habitations. And then Dr. Rachel Armstrong is exploring protocells. She's a researcher in England. And she is taking these protocells and working on a paint. These protocells would be embedded in the paint, painted on a building, and then the paint would absorb the CO2, the pollution, thicken like a shell, and have thermal mass as well. Her Venice project imagines these protocells glomming onto the wood pilings below the city, reinforcing it so it stops sinking. She's a senior TED fellow, by the way. It sounds crazy, but I think, Alexander Bell had a notion about talking to people through space, and who in this room doesn't have a cell phone? So we've been building the same way for a long time, stick by stick, brick by brick, so many layers and so much waste. Conventional building practices are evolving and are giving way to more adaptive solutions. But we must really retool our thinking, and I believe rapid prototyping will really lead towards zero waste or near zero waste construction. Biomimicry is teaching us about the genius of nature and how materials, instead of producing CO2, can consume CO2. Recycling and these practices are great, important, but it's really conventional thinking optimized. So with nature as a guide, we can begin to look at CO2 not as the poison of our time, but as feedstock. Nature is teaching us about thermoregulation. It's teaching us how to maintain constant internal temperatures in our buildings through careful calibration of the envelope, its systems, and their relationship to the sun and to wind currents. And as we continue to evolve, the distinction between materials and methods will begin to dissolve. Extraction, production, manufacturing, transit, construction will all collapse into one process called self-assembly. Buildings will self-assemble. This is architecture of the fittest. Thank you.